Hi everyone, in this video we are going to begin discussing ionic formulas. And so the big question I always get when we talk about ionic formulas is how are you actually going to know, how can you predict what type of anion or cation is going to form? And so I have two pieces of advice and then one table that's going to help. So the first thing, anions want 8 valence electrons, if they can help it. If there's any way possible, they want to have a total of 8 valence electrons. So they're going to continue to gain electrons until they hit that magic 8 number. Whereas on the other side, our cations, so our positive pieces, want to lose as many electrons as they possibly can till they can get to 0 valence electrons. And I'm going to put it in quotes. Because technically, when they lose all of their electrons and they've lost everything in their outer shell, they've gone down so they only have their electrons in their inner shell, technically they now have a complete electron shell, and so they technically have 8 electrons. But in our minds, they've lost all of their valence electrons, so they've gone down to 0. But I do want you to understand the difference. They do have a complete shell. They do have 8 electrons in their outer shell. It's just that they used to have an additional shell, and they've lost all those electrons. So hopefully when we look at a graph, that will make a little bit more sense. So let's go to this little table. So there are easy ways to predict what type of cations and anions are going to actually form. And so the big thing is everybody wants to become a noble gas. That is the goal. Everything they want to do to form this structure right here. So they either want to lose all their electrons to become a noble gas, or they want to gain as many electrons as possible to become a noble gas. So let's start off by looking at lithium. Lithium is right here, and it has 3 total electrons, 1 valence electron. So we know that it's on the left side of the periodic table. It's a metal. It definitely wants to give up its electrons so that it can easily have its inner shell that's complete. And so it has 3 electrons total. If we lose this 1 electron here, technically now lithium is behaving like helium, like that noble gas, and so it has that complete inner shell. So it wants to lose 1. Same thing goes for everything here in group 1. So all of these want to become +1 in terms of cations. So now if we go over one step and we look at our second group, so our magnesium, our calciums, and so on and so forth, magnesium wants to lose 1. Okay, so if it loses an electron there, now it's sitting at sodium's configuration. Now it just has 1 external electron, or 1 valence electron. That's not good enough for it. It needs to lose a secondary electron. Now when that happens, it comes all the way over here, and now it has the noble gas configuration of neon. So it's super happy. And so everything in that group 2 wants to actually become a +2 cation. So magnesium, calcium, strontium, barium, they all want to be +2. So now I'm going to jump over to the other side here for my anions, and I want to start off by looking at fluorine. Fluorine typically has 7 valence electrons. It desperately wants to get an additional electron. It wants to have that stable noble gas configuration. Remember, when these elements or these anions or cations get a full shell, it provides stability. So their electron energy level actually drops, and so it becomes more stable. So that's the whole point of this. So fluorine is desperately trying to gain 1 more electron so it can also have the noble gas configuration of neon. So fluorine wants to gain 1. And so what we know then is that all of these anions in this group want to become -1. So if we go over one more and look at oxygen, if it just loses 1, then it's at the configuration of fluorine. That's terrible for it. It doesn't want that. That's 7 valence electrons. It needs to gain 1 more electron and actually have the configuration of neon. So everything in group 2 wants to become a -2. And so for this course, we're just going to focus on oxygen and sulfur. The last one I want to point out is nitrogen, and nitrogen clearly has a -3 charge, and that's because nitrogen needs to give up 1, 2, 3 electrons in order to have the noble gas configuration of neon. So hopefully that makes sense to you. Now in the center here, we have some transition metals that have different types of charges, I would say. And so most of these want to become cations, most of these metals do. And so what we're showing you here is that the ones in red have 2 or more different electron configurations or charges that they prefer. And so something like chromium wants to be +3 or +6, iron is +2, +3, copper +1, +2, or we have ones like zinc that is always +2, cadmium always +2, silver always +1. So these are all the ones that kind of vary. I will never expect you to know those. I don't expect you to know that at all. Anything in that center, I don't expect you to know. However, anything that's right here Okay, so in your S block, these +1, +2, you definitely need to know. And then anything over here, these blue ones on this side, I definitely expect you to know those as well. So anything that's natural, what's very, very natural, something that would be obvious for you to understand and easily memorize and recall by looking at a periodic table. That's what I expect. All right, so now I'm going to move this away so you can't look at it. So now just using your brain and what we just talked about. Strontium wants to become a cation for sure. Now, in an ideal case, what's going to be the charge of it? Okay, go. All right, did you get an answer? Hopefully you said +2. Strontium definitely would do anything it possibly can to become strontium +2 so that it can lose 2 electrons. Now, why is that? If you find strontium over here, we can see, you can see it's right there in group 2. And so what it wants to do is lose 1 and then 2 different sections, 2 electrons, and then it can have the noble gas configuration. Okay, so it's beautiful. Next question. What about nitrogen? So nitrogen definitely wants to become an anion. So what is its charge going to be in an ideal situation? Go. All right, did you get an answer? Hopefully you did, and hopefully what you were able to see is that nitrogen desperately wants to seek 3 electrons in order to have its most stable version of itself. So it definitely wants to become nitrogen 3-. And the way you can determine that is you look at your periodic table. We can see that nitrogen is right here, and if you were looking at a regular periodic table, it wouldn't just say -3, but you would see that you can lose 1, 2, and then 3 electrons in order to reach the noble gas configuration of neon, which provides stability, okay? So that it definitely wants to gain 3 electrons. Now, my question is, what happens if I want to create some kind of ionic compound by using the strontium 2+ cation and a chlorine- anion? Okay, so let me draw a line here to separate it so it's very clear. How do we know what we're going to predict? What type of ionic compound is going to be formed by combining these 2 atoms, or ions, I should say? So the first thing you do when you're trying to figure this out is you draw out your ion, and then you draw its charges. So I see strontium 2+, so in my mind I think, okay, there's a plus and a plus. There's 2 total plus charges. Now, I know that all ionic compounds are neutral. They have an overall neutral charge, so an overall charge of 0. So in order to balance out my strontium, I need to put a chlorine here that has a -1, so these 2 cancel each other out, but I still have a +1 charge right here. So I need a secondary chlorine that has a negative charge to cancel this charge out. Now I have an ionic compound that's complete. And so what I can see right here is that for every 1 strontium I have to have 2 chlorines. So my ionic compound, or my lattice, is always going to be formed with every 1 strontium to every 2 chlorines that are going to be surrounding it. Now, another way you can do this without drawing this out is you can draw out your strontium 2+, have a little charge there, and a chlorine-. And so what you do is you basically crisscross. And so the minus goes down to the subscript of the strontium, the +2 goes down to the subscript of the chlorine. So if you redraw that, you would see the strontium has the -1, so we don't write 1s, and then we have chlorines, which has a 2, so you just write the 2. The actual charge, the minus or the plus, you don't write that there. We don't ever put positive or minus in the subscript section, okay? So that's what we would have if we combine strontium and chlorine. Let's do another one. What if we combine sodium plus and nitrogen 3-? If you want to pause right here and try to do it yourself, you're absolutely welcome to do so. Otherwise, I'm going to continue working it out. So I always start with my biggest charge. To me, that just makes the most sense. And so right here, I see that I have nitrogen with 3- charges on it. So 1, 2, and 3. And now I know that I'm going to be able to use sodium as my counter ion to try to cancel each other out. So my sodium is a +1 charge, so I write 1 sodium here for a +1. My plus and minus cancel each other out. Great, but I still have a minus over here, so I need to add another sodium. These 2 cancel each other out. Wonderful. Still have an additional minus, so I need 1 more sodium cation in order to cancel these out. Added that together, they all cancel out. So what I can see is that I have 1 nitrogen for every 3 sodiums. All right, and usually you write your cation first and then your anion. So my formula here would be Na3N. And again, if you wanted to do the little cross situation, cross method, whatever you want to call that, where you take the 3 down here, the positive goes down here, and then you just rewrite it. So you would say you have Na3N, and then it's a +1, but we don't write our 1s. Hopefully this is making sense. Let me give you one to try at home. So strontium 2+ plus nitrogen 3-. I'm looking for the ionic compound, the actual formula, the empirical formula. Go. All right, did you get an answer? Hopefully you did. I'm going to show you both ways, the long way and the short way. So the first thing you do is you start off with your big charge. So I see nitrogen has a -3, so -1, -1, -1 for an overall -3. Now I take my strontium. Strontium has 2 positives, so a plus and a plus. So right away I see that these 2 cancel out and these 2 cancel out. But now I still have a minus left over, so I definitely need another strontium. So here's a positive, here's a positive. So my minus and my positive cross each other out, but now I have a leftover positive. So my strontium isn't canceled out. So I need another nitrogen. So I do another nitrogen, which has 3 minuses. So 1, 2, and 3. So here now, my positive and negatives cancel each other out. Now I have 2 minuses left over, so I need to add another strontium. So positive, positive, my positive negative cancel out, my positive negative cancel out. Now I have my complete structure. So if you go through, you can see you have 1, 2 nitrogens, and you have 1, 2, 3 strontium. So your formula ends up being Sr3N2. Or if you wanted to do it the really easy way, you could have just gone Sr2 plus and then N3 minus. The 3 goes down here, the 2 goes down here, and you end up with strontium 3, nitrogen 2, okay? I am completely fine with you using this method, but I need you to understand that this is why that happens. We're trying to cancel out the charge. If you don't understand this weird, messy part, then this is just going through the motions and you're just a robot, and that's not good. We want you to actually understand it. All right, the last thing I'm going to do is something just one step further back. So this, what I'm about to write here, is a classic exam question for you. So what is the chemical formula for the ionic compound formed from aluminum and oxygen? Okay, so now what you have to do is first decide if it's going to be a cation or anion. Then you have to decide what the charge is going to be on it. Then you have to do everything we just did here, where you actually bring them together and try to determine what that actual formula or a chemical formula is going to be for that ionic compound. Good luck, you can do it, go. All right, did you get an answer? Hopefully you did, but this was definitely trickier. The first thing you do is you write out your aluminum and your oxygen, and you say you're trying to predict something over here. So you just try to get your skeletal formula out. Now you have to go and assign the ions. So we know oxygen is in group 2. It's always going to have a -2 charge here. But aluminum is kind of one of those weird ones. So what you could do is one of 2 things. You could go back up here and look and see that you actually have aluminum all the way over here in the periodic table in group 3, and we can clearly see that it has that +3 charge right there. Or you can look at it and say, okay, I know I'm in group 3. It's a very simple course here. We're in chemistry for context, so most likely it's going to be a +3 charge. And to be completely honest, I'm never going to give you an ion or a cation that is in one group and has an opposite charge. That's just cruel, and there's no way for you to actually know how to do that otherwise. So by looking at this, you see aluminum's in group 3. You know it's a metal. It definitely wants to become a cation. It has to be aluminum 3+. Now you move on to the next step. So you can draw everything out, which just like I did before with the strontium nitride one, or you can just do the crosses. So you know the 3 goes down here, 2 goes down here, and if you did this properly, you would end up with aluminum 2O3, or aluminum oxide, okay? Have a great week. Take care of yourself. If this doesn't make sense, practice, 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 and drink a lot of water.